4-3 day 2. Now they're going to throw a little curveball at you. It's not much of a curveball, okay? Person's just learning how to throw a curve. It's not a big deal. All right, what do we got here? Well, we're multiplying fractions. If I said to you guys, hey, do it, I got a feeling you would go 2 times 9 is 18, 3 times 10 is 30. Then you go, hey, 6 goes into both of these, so I'd have 3/5. Raise your hand if that's you. I thought so. Now, everybody, put your arms like this. Repeat after me. That'd be your left arm. My left arm is a fraction. My right arm is a fraction. When I multiply fractions, I cross-reduce. And I swoosh. Okay. Weird? Yeah. Does it work? Mm-hmm. Am I multiplying fractions? Yes. Instead of doing this, we're going to go, 2 goes into 2 once, 2 goes into 10 5 times, cross-reduce, 3 goes into 3 once, 3 goes into 9 3 times. Now I swoosh. What does that mean? Multiply the top together, multiply the bottom together. So I get 3/5. Now some of you are like, well, I like that way. Don't make me do something I don't want to do. Well, good luck. Why do you think I'm showing you this? Because you're going to get some nasty problems coming up. If you don't do it this way, it's going to be a nightmare. I promise you. Example 2, it's not too big of a deal. It says, find the product of this quotient, this fraction and this fraction, this rational expression and this rational expression. Don't get intimidated by all those words. So product means multiply. Okay, wait a minute. When I multiply fractions, what do? Cross-reduce. So I'm going to say, okay, let's check this out. 2, that's a z. That's why it's important to put a little slashy line in algebra class on your z's. 2 goes into 2 once, I could put a 1. 2 goes into 4 twice. Notice I got a y here, and I got a y here. Now why can I cancel these? Because everything's mushed together by multiplication. Remember our previous lesson? And now, that's all I can see as far as like cross-reducing stuff. So now I'm going to swoosh. So everything in the top, I got 3 times 1 is 3. X squared times x is x cubed. And now I got a 2, look like a z, times z squared. So 2z squared. There's nothing else I can do. So there we go. Now, if you forgot to like cancel some stuff and you end up with this and there's more you can do, you should continue canceling things. But I got everything. But you can kind of see where this is going. Some of these can get nasty. The next problem's going to be a little nasty. All right, I promised you it'd be nasty. Here it is. Find the product. Okay? Well, so it's like, oh, okay, you told me to cross-reduce swoosh, so I'm going to cancel these out and, take these x's out. You must not have been listening to 4-3 day 1. How are all these things connected? By addition. Addition, subtraction. Don't forget the golden rule. Factor, factor, then factor, factor. And that means factor everything, every spot. So there's 1, 2, 3, 4, 5, 6 little problems that I got to go, ooh, can that be factored? This, nope, not going anywhere. This, nope. And another hint. When you see a binomial, slap some parentheses around it. It'll help your brain be organized when you get to the packing phase. Times, here's a Gauss one, and it's a trinomial. So I'm going to go like this. X and x. What are 2 factors of -6 to f to 1? 3 and -2. Now, hopefully you're getting better and better at factoring trinomials. We've been working on them. And then this is a perfect square trinomial. So I'm going to write it like this. Now, what can I take out of here? An x. What's left? X plus 1. What can I take out of here? A 5 times x minus 2. Well, there's the hard work, and now here comes the reward. Pause. When they ask you find the domain, it is at this point, once everything's been factored, that you should find the domain, not after everything's been simplified. It's right now. What are all the things that x can't equal? Well, x cannot equal -3, -1, same thing here, but I'm not going to write it again, and 2. Okay? There's your domain. Now the hack fest. Look for stuff that's the same. X plus 1, I could pick either one of these. I'm going to pick this one. X plus 3, X minus 2. And look at this little treat. I got a 5 and a 5. And now, what is the only thing that remains? X, X, and that. Now, I'm going to swoosh. X times X is X squared, and then I'm left with X plus 1. This is my answer. Now notice if I think, oh, what's the domain of this? I'm going to go X can't equal -1. That's only part of the story. The real story is right here from the after we get done factoring. So that would not be right. So don't wait until you get to your answer to find your domain. It's after you factor it. In this section, they're going to add some division problems. So we've got to go back to our memory bank and go, I think I remember this. Here are the rules. The first fraction, don't mess with it. This turns into multiplication. What do you do with this every time? Flip it. See, it's just a different way of giving you the same sort of stuff. So it's like an extra step. Now we factor, 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 factor. But obviously there's nothing to factor. So what do? Cross reduce, swoosh. So 3 goes into 3 once, 3 goes into 9 3 times, 1 and a 4, swoosh, we get 3/4. Now, is that the way your homework problems are going to be? No. It's just getting the ball rolling. All right? So, piggybacking this problem says find the quotient of. What does this mean? It means divide. Well, all that means is take the first one and divide it by the second one. Don't you start factoring yet. Do this first step. The first one stays the same. Division turns into multiplication. Now we flip that one, the second one. And now we think, okay, factor. So the 1, not going anywhere. What do we take out of there? An x. That would leave me with x plus 9 times, what can I take out of here? 3 and 18, I can take a 3 out. I can also take an x out, and that would leave me with x minus 6. And notice I said, hey, if you see this binomial floating around, don't look at it as two things. Slap some parentheses around it. Make it one thing, because you're looking for binomials that are the same or exact opposites. Hint, hint. So, first of all, I'm going to take these little x's out. And I look at this. Now, those of you who just kind of have it memorized, like, hey, x and negative x, those are opposites. -6 and 6, those are opposites. So you might cancel those out and then just put a -1 in the front. Now, the reason I didn't cancel it out, because some of you don't like that technique, or you might not recognize it. You can take a -1 out of here or here. So I'm going to take a -1 out of here just because I have more space. That would make this negative and that positive. And then they're rearranged differently, but I can see now they're the same. So now what do you do with a -1? Typically when you're dealing with fractions, you put it in the top. So now I'm going to swoosh. 1 times 3 is 3, but I'm going to bring that negative up with the numerator. There's a reason for that, but I'm not going to bore you. And then x plus 9. Why did I take the parentheses off? Because I can see we're done. If you want to keep them, that's fine too.